Okay, another example. All right, so some company, manufacturing company has a machine must be serviced if its defect rate exceeds 5%. Now, um, the company is supposed to be keeping track of large numbers of manufactured items and to get the rate, but it didn't, and it wants to do a quick run of 50 test items to determine if the rate is 5%. Well, it runs it, and it thinks kind of bad news. It finds 4 that are defective, which it knows is more than 5%. But since it's statistical, it wants to use statistics to argue um, whether or not this supports the claim that the machine should be serviced. Okay, and it will use an alpha equals 0.05 test. So one way to do this is suppose we consider we consider each item to be a Bernoulli item. So yi is Bernoulli p. So yi Bernoulli p is 1 if item I has defect and otherwise else is 0. Okay, so one way to do this test is we want to test whether p is 0.05. Now I use 0.05 for alpha too, but this is a different 0.05. So we want to test whether the probability of a defect is 5%, 0.05. So we want to test 0.05 versus greater than 0.05. So I put the equality in the null hypothesis, and I want to test whether it's reasonable whether we can reject the null hypothesis and claim that indeed the service rate is greater than or at least 5%. So one thing we can do here now is we see I wrote all this down ahead of time, so this makes sense, right? I will let the test statistic be the sum of the 50, basically a count of how many defects there are, and I will reject if the count is sufficiently big. Now, if the count is always going to be bigger than 0, so I wouldn't pick 0. Well, no, you could pick 0, so that would imply that you would reject if there were any, if there was even 1. All right, so k could be 0, it could be a half, it could be 1, 1.5, etc. Right? So, what do we pick for k? All right, so to find k, to find k, we notice that alpha is equal to the probability that we choose HA given H0 is true. So probability we choose HA chosen given H0 true, which is less than or equal to probability HA chosen. HA will be chosen if Y star is greater than K, given H0 is true. And here's the less than or equal, and that has to do with this less than or equal. The highest probability of this error will come when P is exactly 0.05. If P is less, you're going to be less likely to exceed a threshold K. So this is given P equals 0.05, right? Okay, now at this point, I could use the binomial formula or in R, or I can use the central limit theorem again, because remember, binomial is just the sum of independent random variables. So the central limit theorem does apply, and we can say this is equal to, using the central limit theorem or the normal approximation to the binomial or the Moivre-Laplace theorem, we could say this is approximately the probability y is greater than k, where y is given y is normal, NP, right? NP would be, what the hell's NP? 2.5. So let's just write NP and NP 1 minus P here. Okay, so this is central limit theorem. Okay, now I get, if I do this, this is equal to probability y is greater than k, and y is normal 2.5, so that's the mean, and the variance is 0.11875, I get. Okay, all right, so for 0.05, for alpha equals 0.05, running out of paper. So for alpha equals 0.05, we want, all right, so this is equal to, so now I do the, I'll transform this, right? If y has this distribution, this is the probability z, which is normal 0, 1, is greater than k minus 2.5 over square root 0.11875. Okay, and for alpha equal 0.05, we want, now we're on the right side, right? So we want the probability that we reject, in other words, the probability that z is greater than this has to be 0.05, okay? So we want this to be Q norm 0.95. So that's where these pictures can be helpful. Okay, so this should be where I reject z, right? So we want z, we want this k minus 2.5 over this square root 0.11875 to be equal to Q norm 0.95, which is equal to 1.645, which gives k equals 2.5. Now this is positive this time, plus 1.645 times the square root 0.11875. And did I do this? Yes, this is equal to, which is equal to 3.07. So I will reject if y is greater than 3.07. Okay, so since y, the number, the sum of yi was equal to 4, we reject H0 and claim service is needed. Okay. Now, can we find the p-value of this one too? I say this now and not having done this again. So what would the p-value be here? The p-value would be the smallest alpha where I reject. So again, if you want, you can think of this as, make a little table till you get the feeling of this. We'll make a table of k and alpha. So if I have a table here, I'll make it this way, k and alpha here. And say we have alpha's 0.05, we got k, this is our threshold here, 3.07. What if alpha's 0.01? Did I do it? I hope I did it. If alpha's 0.01, did I do it? Maybe didn't do it. Okay, let's do it. So if alpha is 0.01, we just have to compute that, right? So the 1.645 changes into Q norm of 0.99. So we get K equals 2.5 plus 2.33 times square root of 0.11875. I get 3.3. So still, I reject here, so I get 3.3. What if I had 0.005? What would I get there? If I do it there, I get, Q norm 0.995. I get 3.4 about. This is about, it's about 3.9 actually. So if I come here, the question is at 4, what is this p here? So this is the p value. It's the probability at 4, okay, at the test statistic. So you say, what's the p-value of the test? It means for the observed samples. So what I need to do here is go back and solve here. So we have 4 equals 2.5 times, now this was plus Q norm. Q norm, this would be 1 minus the p-value, and times square root 0.11875. Okay, so if I now subtract 2.5, and this should be times this, right? Times this. So I have 1.5 divided by square root 0.11875, which is equal to, so I have 1, 4.35, so this is 4.35, and I want this equal to Q norm 1 minus the p-value. So we have 1 minus the p-value equals p norm 4.35. So we take p norm of this, and we get a lot of 9s there. So this is equal to, after I subtract 1, yep, so I get p-val equals 6.7 times 10 to the minus 6th. Okay, another small p-value, which says that we could have made the test even more strict and to prevent error and still have rejected the null hypothesis. In a sense, it is more evidence than if it were bigger. Okay, so just wanted to give you another example of the p-value. So the definition the p-value for a test is the smallest level, or the inf of the levels, at which H0 is rejected. Okay, sorry for trying to jam too much into this lecture, but that was good. We finished that idea there. So stay tuned. We'll move on to some of the other topics coming up in the next lecture.